High technology from China, HVPD-SW-IR Sonic Wave Infrared Thermal Partial Discharge Detector.
Open the sonar positioning software. Wait for the screen to appear. You can see the picture. Next to it is a frequency. You can choose the frequency color block. Leave it alone at first. Now open a test item. Turn on this 1000 volts ultra small voltage generator. There is a broken leak point on it. Iron box is a natural screen, so it will not cause electric shock to human body. There will form an arc here. There is a sound coming out. You can see yellow sensitive area is large. Swipe blue positioning slider to yellow sensitive area. You can locate this discharge point of the tested object. If you swipe away, blue slider is not in yellow peak area, and the real-time discharge point cannot be seen on the object picture. It's gone, so choose to be in a very high area. You can locate the point. If you think the anchor is jumping, can click here. Here sensitivity is 60, which is 60 by default. If there is a lot of noise on site, can set to 55 to make the positioning more accurate. Here are screenshots. Here is video. Click. You can record what is tested now. Here is the time of video. Click again. The video can be played back. Infrared thermography. Click. Go back first. Plug in the infrared camera first. Infrared thermal imager. Open. Plug it in top of instrument. Then click button for infrared thermography. It will recognize, can see picture of an infrared thermal image, can choose other colors here. Select high contrast, red, regional temperature measurement, can draw an area, can see where has discharge point. It's the brightest, the highest temperature. The instrument can automatically locate. Line area, can move tested object to this line. It can localize the point. It shows the point of highest temperature. You can also draw a dot, can check the temperature values of many different points. But if you don't do anything, it can automatically capture the highest point. You can see that as the camera moves. The temperature value will change in real time. Take screenshots. You can see the highest point in the screenshot. Draw a frame. The maximum and minimum temperatures are automatically recognized in the box. Can take a screenshot. Okay, when collecting sound, when collecting various types of ultrasound, you can put earphones on your head to listen to the sound. Long press the switch here and it will light up. With a power on notify sound, put it on your head. When collecting ultrasound, when receiving the ultrasound, it will have an audio prompt. Check here to see if the audio is turned on. Turn it on. Click to start detection. At that point, the ultrasound we collect will be converted into sound that humans can hear. The earphone and the host are Bluetooth connected. The sound heard through headphones is quite distinct, resembling white noise. If there's even a small sound in here, there will be white noise in the earphones. Slight friction, there is white noise. It's sensitive. It will also be displayed on the chart. Our instruments have been successfully used by China country's railway authorities to detect and identify gas leaks in pipelines, effectively preventing accidents. Now let's demonstrate and simulate it. The collector has a built-in ultrasonic sensor. The host has started to detect. Now blow through my mouth. The spectral characteristics show the 2 gentle blows I just blew have been detected. Therefore, our instrument can be used to detect gas leaks in tested objects such as pipelines or gas-filled cabinets. Similarly, flexible ultrasonic sensors can also detect gas leaks. Plugged into the middle interface of collector, detect channel adjust to flexible sensor channel. Look to the left, now it is stationary. Blow into the probe. Can also see obvious features. Similarly, wireless ultrasonic concentrators can also detect gas leaks. Look at the channel on the right. Is also in detection state. Now I blow air. You can also see a significant change in the map on the right channel. Open the PD software. Jumping interface. Partial discharge test page. IC to channels. PD collector. Long press to turn on, and release when you hear a beep. After the connection is successful, it will become a state. Channel 1 will be automatically connected. Words here will turn black. Click to switch sensors. Click to start sampling. Now PD instrument starts sampling. PD collector. This is an open ultrasound. At the bottom is the ground wave function. This is a simulated test preparation. When testing, align it with the gap in the cabinet. Like this, all the gaps have to be swept. Can suck on SwitchGear cabinet surface. Click sensor switching button. Switch to TEV. The indicator light switches to TEV mode. Perform TEV mode detection. Connect external sensor to use, take it off at first. 3 ports at bottom. UHF, Ixton HVPD. Connect high frequency transformer. Connect to port at right. Attach sensor to the cable under test. The way of opening and closing is like this. Just put collector next to it. Host switches to HVPD mode. It's testing. Connection of other sensors. Contact ultrasound is connected to the extent in the middle. Suppose this is a transformer. Coupling agent can be applied. Effect mode. Coupling agent. How to use. Open the coupling agent. If there is no coupler, you can use toothpaste or other paste instead. Put a little on the touch point and then suck it together. Increase their contact area to enhance the signal. Host page switch to XCUs. It is being detected. Contact sensor for GIS measurement. Connect it. In the same way, let's say this is a GIS shell. Also necessarily apply coupling agent to center point of contact surface. Magnetic attraction. Switch to GIS on the host. GCUS. It will automatically jump to detect. Look at the picture. Similarly, flexible sensor is also connected to extend in the middle. Flexible sensors are mainly used to test the gap of SwitchGear, consistent with internal ultrasound function and detection method of collector. If there is a place that cannot be reached, can bend flexible sensor and test top area of SwitchGear. Or inspect the inside of gap. UHF sensor is mainly used to test GIS. UHF sensor is mainly used to test GIS. Suction like this first, the other end connect to UHF port. Wire is also tagged with UHF. Let's say this is an insulating basin for a GIS. There are 3 colors of yellow, green, and red at the insulating basin, representing 3 phases. Attach sensor tightly to insulating basin for testing. The yellow, green, and red of all insulating basins must be measured separately. Select UHF gear on the host, then bring the sensor close to all the insulation pots. Insulating basins are generally divided into 3 points of yellow, green, and red, indicating 3 phases. Each phase need to be tested. Ultrasonic concentrator. Open. Long press, hear a sound, release. There is a red light indicating. The red light indicator is an indicator at a long distance. So, for example, a test site. You can aim at it. Click Start Testing on Instrument. There is an image at channel 2. If the value fluctuates, it indicates that there is interference. It is mainly used to test the insulation index of overhead lines, the outgoing line of transformers, and cable joints. Now let's talk about the various functions on the instrument. As you can see, there is Figure 1, Chart 2, and Chart 3. Chart 1 has per pod and perps, 2-dimensional map, 3-dimensional spectrum. Abscissa is phase. Vertical axis is amplitude. Similarly, this is XZY. Z-axis is amplitude. X is the phase. Y-axis is time. Press Chart 2. It's a flight chart. Flight time domain diagram is a time domain diagram for each period. Figure 3 is the histogram. Displays the value when there is a value at a certain point. Below are the parameters. Screenshot function. This is screenshot. It's a video. Click, it will turn into time. How many seconds? Click it again to stop. Click it. Click here to save PD data. Progress bar. It's saved after showing 100%. Jumped. Select a folder. Click Save. You can see it's saved. Wave concentrator and UHF. There will be special icons on the front. Click. This is the sampling parameter of sensor. Click Export to export as a chart. Turned into a chart is the report. The report can be freely edited. For example, click here and edit it. Click Save. OK, click back. There are touch buttons on the screen. Save, Start Detection, Stop Detection, Refresh Historical Data, Settings, Set, Preset Setting, Cycle, Network Settings, Feature Key, Time Setting, Version Information, Manual, you can see User Manual, Entity Key, Setting Key, History Data, Function Switch Partial Discharge Detection, Return, Up, Down, Left, Right. Battery amount of collector. The power of the channel 1 collector is displayed here, has 83%. Channel 2 is a condenser. The power is displayed here. On the top of instrument is power button. Camera function. Click it. You will enter the photo page. The function of taking pictures is as follows. In the saved data, click on these 3 dots. See the appendix. Click it. Can click plus sign here to take photo and add it in report. Suppose the tested subject is this. Take a picture of the subject here. OK, and then when exporting the report, you can see that there is a photo of the tested object at the bottom. Photo here. and on file list page, there will also be a picture shown on the right, mean that there is a picture attachment in this file. Open the lid on the left, USB Type-C interface, and this network interface is useful only in China and not useful outside China. USB interface can plug in USB stick in the USB port. Take out the USB stick, plug it in this place. Then when you click on data, there will display export to USB device. All the test data is imported to the USB device. Wait 9 seconds, then plug out the USB drive to let the data saved completely inside safely. Type-C port is a charging port. Use this charger to charge. Charge with our charging cable charging head. If want to replace charger, bias per parameters of our charging head to avoid different parameters causing damage to battery and/or main board. After connecting, use the power supply of 110 or 220 to charge. When charging, the light is red. In the upper right corner, you can check the power of the host. There are also function expansion keys at the top. You can expand the infrared function, and you can also expand other devices. Just plug iCamera in. You can pull it directly after use. It supports hot plugging. Click back. Selection interface with PD and Sonic. It will prompt whether to shut down. There's a 20-second wait time. It will shut down automatically. Long press here to shut down. Similarly, long press here to turn on. When hear beep sound, can release finger. It is turned on. Wait opening interface. The use of straps. Connect the two straps. So when testing, hang the host around your neck. It is convenient to operate the sensor by hand. During test, you can also hold host in one hand to watch test interface and operate sensor in another hand. You don't need it. You can take it off.
Thanks for watching the tutorial video prepared by HD Yoga Manufacturing.